Hello everyone, welcome to the fourth Black and AI workshop. My name is Hassan and today I'll be talking to you about NUBIA, a neural evaluation metric for text generation. In this talk, I will talk about first the motivation for this work, the key insight behind NUBIA, the architecture, experiment and result, as well as the discussion and future work. So the backstory of NUBIA started around February 2019, where I was working with some friends on document similarity. We wanted to try an idea, which is, could we take two documents, say two news articles about the same fact, run them through a summarizer, or just see the headline, compare the summary of the headline, and use that as a proxy for document similarity. We quickly stumbled upon a problem, which is defining a metric for similarity across two summary. So our initial thought was that it would be very easy, that would take the latest architecture that embed sentence, do something with their hidden state, and voila, that would then be too much of a problem. However, when we actually learned about how people were evaluating summary, we stumbled upon bleu and rouge. And for people who may not know about it, bleu and rouge were metrics that were designed around 2002 and 2004. And the way that they compare to sentence, or sorry, to summary, is that they look at the overlap in word between them. Often they may do more than the word, and they may look at bigrams or trigram. The point is, it's still a very, look at the overlap in words, whereas you can say a sentence in multiple ways using synonyms, and those metrics may not be robust to this kind of transformation. So we found that it was very suspicious. And just to see how recently those metrics are used, they're actually the metrics still used to this day. So when, for example, Microsoft earlier this year came up with this Turing language model, you had a sentence like this in the paper where they say, since rouge evaluation is known to be flawed, or for summarization tasks, we would do this, or since rouge score don't always capture other aspect of quality, but people would kind of brush upon that. Yeah, these evaluation metrics are a bit flawed, but this is kind of what we have. And same thing for GPT-3 that was released earlier this year in May. And you would find sentiment like that across Twitter, where people would say that blue score sucks, and that all reference, which is basically counting the words-based evaluation metrics, have the same defect. Similarly, people would say, oh, this score sucks, but there's no alternative. And that's on a repo that tried to basically rank summarization model by how good they are. There's a big warning: evaluation metrics. The Rouge and Meteor have serious limitation. So we found that very, very suspicious and decided to work on that problem. So the picture when we started this project around February 2019 was that we were, as a machine learning community, working on increasingly powerful language generation techniques, but our evaluation methodology was stuck in early 2002 and early 2004. And people were increasingly dissatisfied. And so we asked, what does a path forward look like? And a little bit of context is that unlike other tasks, such as regression or classification, text generation, the golden standard is human evaluation. But we often cannot have the luxury to do human evaluation, so we often need to use proxy, such as automatic evaluation metrics. But given the nature of those metrics often have to evolve, and this was something that wasn't quite happening when we started this project. So the key insight behind NUBIA is that before our work, a lot of people were treating it as a formula problem. People were thinking about, how do we find the correct formula? And a lot of people propose different formulas, or how you would take a sentence and do something with the embedding, or do something with the TF-IDF of the various words. And we scratched all of those approach, and we started from first principle and think about how would we tackle this. And it became relatively obvious to us that the way to do it was to treat it as a machine learning problem and move away from human-derived formula and let the algorithm come up with the way that they would want to have that happen. So we moved away from a formula-driven approach to basically what we call NUBIA, which is we take a reference and candidate sentence, run them through what we call neural feature extractor, and then there's a network that looks at how different neural features correlate with a human score, and that's the work that so NUBIA is a general methodology to evaluate sentence interchangeability using this approach, but it's also proof of concept because we've actually implemented and tested it. And so the kind of question that we now have to ask are like, what are those exact neural feature extractor look like, and how do we train this network that maps from those features to a score of quality and make it on a scale of 0 to 1? And how does it do? So for the first dimension, we try a different approach, but we ended up converging on a transformer architecture that was fine-tuned on semantic similarity. So we take a already trained transformer, we fine-tune it on semantic similarity, and this one was achieving a 0.92 correlation with human judgment. So for logical inference, we take similarly a transformer and we fine-tune it on taking a candidate and a reference sentence and outputting a probability distribution on whether it thinks that the sentence are in agreement with each other or not. And for the last one, that's one where we're trying to basically understand how well written the candidate and reference sentence were. And so there we use the perplexity of a language model on the candidate and reference sentence. So now that we had our feature extractor, how do we train this aggregator? So we then went on the WMT competition, which is basically a yearly competition where one of the subtasks is to evaluate the quality of machine translation. So each year, people are encouraged to develop models that take a reference translation and a candidate translation, and humans score them actually on a scale of 1 to 5. And then the systems are measured by how well they do with this approach. So for our NUBIA model, the final NUBIA model is trained on only actually 9,000 sentences. And we tested it on the paper on 3,000, so for the one that's tested on 3,000 sentences, we train on 5,000. Then for the 2018 and 2019, we tested on 200,000 sentences. And we also actually replicate this for the subject of image captioning, where we actually just take the network, train it on assessment of machine translation, and see how it does transfer learning, where in the setup of image caption evaluation, you have 5 sentences that describe the image and the candidate sentence, and the goal is to see how well the candidate sentence agree with the various description of the same image. So for the case of the WMT 17, for example, we can see that the average correlation of bleu and rouge fares around 0.48 to 0.42. And NUBIA, the best models of NUBIA are able to get actually 0.77. So it's a huge jump in performance. And actually at the same time that we're doing this work, Google also worked on a similar metric called BLERT, and some prof at Cornell also work on a metric called BERT score. And so we're able to actually achieve better result than BERT score. And so far only BLERT does better. And then on the test for image caption evaluation, where this time we take a model that's trained on 9,000 machine translation, and we test how well it agrees with human judgment in the context of image captioning, we're actually able to achieve a state-of-the-art result, where this time we actually do better than BLERT and BERT score at this task. So the NUBIA model seem to have high generalization capability. And so some of the example here to land the point, so we start with this sentence and we substantially modify it such that there's almost no words overlap, but the NUBIA model is able to still see that the sentence are about the same subject and they are in agreement. So it gives a high NUBIA score. And then when you take this sentence and you just change this automobile cost a fortune, purchasing it impossible, and just say purchasing it totally feasible, the NUBIA model is able to realize that now the sentence are in a contradiction, and that affects the NUBIA score in a way where only one word change completely change how the model assess the interchangeability of these two sentences. And so some of the key takeaways is that neural evaluation metrics are a very promising avenue for text generation, and that treating language generation evaluation as a machine learning problem is a promising route, because here we did not devise any formula, we let the models learn. And NUBIA is an advanced proof of concept, but more work is required. And some of the work that we think is required is assessing this model beyond correlation with human judgment. So there was a paper this year at ACL 2020 that talk about behavioral testing, which is designing different scenarios where we see, how well does a model recognize a sentence that's transformed from, say, the active voice to the passive voice, various synonyms and various scenarios. So we think that this is an area where we need to do more assessment. Another application and future line of this work is what we call a generator evaluator training, where the neural metric is used as a loss function for language generation. And actually, one of the very fun facts is that Loic, who is presenting today, actually did that and trained a system on NUBIA that generate high score on NUBIA. Some of the other possibilities include adversarial attacks, trying to understand how these model can be attacked, or fine-tuning for specific application. So to access this work, the title of the paper is NUBIA, Neural-Based Interchangeability Assessor for Text Generation. The website, we made a tiny URL, so tiny URL, NUBIA ML. And, acknowledgement, these are my collaborator, Pelkins, Mohammed, and Ali, and Yusuf. And the meaning behind NUBIA is that it's actually a name of an ancient African civilization from 5,000 years ago that was in or that was around modern day Sudan. And we just want to highlight the richness of resource and skill that the African community can bring to ML. So the final summary is we also the motivation for framing language evaluation as a machine learning problem. We learn how NUBIA is an advanced proof of concept that this is possible, and there's further work required as far as evaluation and developing other application on top of that. And thank you.